All right, we're going to do a polynomial overview. This is the last section of chapter, or unit 6, 6.8. We'll have a test and a review after this. We're just going to overview what we learned this chapter, and we're going to do some of this with your graphing calculator, so make sure you have those out, okay? The first ones we're going to do is number 1 and 2. Go ahead and just get out your calculators. We're going to do this with you. And so letter A, we're going to find the maximum number of turns. We can do that by looking at the equation. Letter B, we're going to actually put this into our calculator, and then we'll be able to look to find the real zeros. Where is the real zeros at for letter B? When we look at it on the graph, what is it?
Where it crosses the x-axis.
Where it crosses the x-axis. So we will put this into our calculator and find where it crosses the x-axis. We're going to approximate those zeros. You have, I'm going to call it an app, but you have a function on your calculator that you can actually find those zeros. These will be decimals. They won't cross nicely.
Gross.
Now we're going to have some new vocabulary for letter D. Approximate the relative minima and maxima. That's like a form of minimum and maximum, okay? And we're going to, the relative, we'll talk about that when we get to it. And then after you've gotten the roots and the minimums, you're going to be able to sketch those on your graph, okay? Let's get started. All right, let's do number 1 by putting it in our graphing calculator. We're going to get up here to the y equal button and put it in. It's going to be x to the 5th minus 4 x to the 3rd plus 5x plus 4. All right, then I graph it, and it looks like this. We have a 0 right here. There's our 1, 0. It crosses the x-axis at one point. So our real zeros are 1. Let's approximate that 0 to the nearest tenth. This graph, even though it looks straight up and down, is slightly slanted. So I want you to realize that you're going to have a left side of that 0 is going to be down here. And the right side is going to be up there. So left will be down and right will be up. We're going to find that 0 by doing second calc. We're going to come over to the number 2. It's asking for a left bound. We're going to need to be below that 0. Hit enter. Then we're going to go above that 0. I'm using my right and left arrows. Then we're going to get as close as we can with that guess. Get as close as we can. I don't think I can get any closer right there. Then it's going to do its math, and we will get negative 1.76, but we want it to the 10th, so it's 8. Negative 1.8 comma 0 will be our 0. The next thing we're going to do is find the relative maximum and minimum. When we do that, I want you to notice we have some new thing here. We have some bumps, and this is kind of like the relative minima and maxima are ways of saying bumps, but it's just a more fancy word. So a higher vocabulary. I've got 1, 2, 3, 4 of them. We're going to find the height of that maximum. It's a maximum because it has a top and the bottom keeps going forever. There's a max right there. So we're going to find the maximum by coming to second calc, coming to max, which is number 4. It's going to ask for the left bound. We're going to be on the left side. Then we're going to move to the right side of that maximum. Then we're going to guess, get as close as we can. That one looks really right there. Hit enter. It's going to be doing its calculations, and we have to the nearest tenth negative 1 point. The 6 raises that to a 4, so negative 1.4 and comma 2.6. You're going to do the same procedure for the rest of that minimum, this maximum, and that minimum. These are the ones we found together, and then you're going to find the rest of them. Pause it now and come back and find those other ones and compare with what I have. Then we'll finish graphing it. Okay, compare your answers with these. If you need to pause it a little, that's fine. But compare your answers with these. And then we're going to start graphing all of them. Now, you could have been graphing each one of these as you go along or do them at the end. but we're going to have some points here. We'll have like 5 points when we have this. We'll have this first one we're going to do is the 0. We're going to do it at negative 1.8 comma 0. And at negative 1.8, here's negative 1, here's negative 2, here's 1.5 or 1.5. We're going to just go a little bit over. Here's your first 0. That's the negative 1.8. Let's do the max, that first one there. The negative 1.4 and 2.6. We're going to scoot over to negative 1.4, which is really close to there. And then we're going to come up the 2.6, somewhere in that area. Somewhere like 2. There. Then we'll have our next one, we'll do our min, negative 0.7 and 1.7. And while you're doing this, keep your calculator open so that you can see how this shape's coming about. We're going to do negative 0.7 and 1.7. So we're going to come over to 0.7 and then 1.7, somewhere in about right there. That's that relative min. Then we're going to go to the next, we're going to go to that max is 0.7, 6.3. So 0.7 is right about there, and 6.3, we're going to come clear up to 6 and 0.3, about right there. Then we're going to do last, we're going to do that min, and it's 1.4 and 5.4. 1.4, not quite there, but about right. 1.4 and 5.4. Here's 5 and 0.4. About right there. Then we're going to sketch this graph. This is where it gets kind of tricky. So you have the calculator picture in front of you, and then you have that these are the mins and the maximums. So you're going to start down low and come through your 0. This is a max, so you're going to curve there and curve back up. I'm going to do that again, but I'm going to make my pin be smaller so that it doesn't cover up all my points. We're going to start down low, come through this. That's a max. Work our way up to a max and a min again, and keep going. I might even make my points darker again so I can see them. And that's how you're going to do numbers 1 and like that for 2 and the rest in that section. All right, we're moving on to number 7. We've got letters A through J, and the first question is the degree odd or even based on that graph? And it's odd because they're going in opposite directions. We're going up that direction and down that direction. So does that make it a negative or positive leading coefficient?
Negative.
Negative because it's actually going downhill from left to right, so it's negative. I like to just put a negative there.
I circle negative.
How many real zeros are there, and how do we know that? How do we find the real zeros on a graph?
3.
Crosses the x-axis. I like to do these with graphs because this puts it in like tangible terms. We can see it. It's not just some equation. So it crosses the x-axis 1, 2, 3 times. So it's 3. How many positive zeros are there?
3. A 2. 1. Sorry.
1. Be really careful over here. Does that go through 0, 0?
No.
If it goes through 0, 0, it's neither positive nor negative, okay? In the past, your positives and negatives had added up to your reals, if you've noticed. But if one of them goes through 0, 0, it won't. But in this case, it does. So, how many negative zeros do we have?
2.
2. Okay. How many turns does this graph have?
4.
I've got a turn right here, 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 and here. By the way, this is at the local maximums and local minimums. I have just, not only have I done number F, now I've done a new one that you have not seen before. I've done I, but the maximum number of terms.
Turns, you mean?
Turns is letter G, and we had 4.
No, that.
No, it says if this is the maximum number of turns, what is the
Oh,
degree?
you're right. 4.
4th, 5th degree.
4th or 5th or 5th or 6th or 7th, or how, what is it?
5th degree.
I thought
What?
it was one below than
It's
the
one-
turns.
The turns is one less than the degree.
If you see the degree, you take one less and get the turns. But if you have the turns, you go one more and get the degree. Okay? So
So
one
the
more.
5th degree?
5th degree.
Okay.
Okay? All right.
So that would make it have 2 imaginary zeros since you have that one hump that's floating. Right?
How many real zeros are there?
2.
3.
You mean imaginary?
How many real zeros are there? There's
Oh,
3.
yeah.
We have to have a total of 5.
So there's 2.
So we must have 2 imaginary.
Or just the
Why
fact that
must we have a total of 5?
Because it's a 5th degree polynomial.
Okay.
Okay.
So
Wait,
there's
you said
two.
you have the turns, it's up 1 to get the degree, you have the degree, it's down 1 to get the turns.
Yes.
Yeah, okay.
Very good. Very good. Here's the new ones. The last 2 are new. We've done all those for a couple of lessons now. Letter I.
Wait, so are we just placing dots there?
Place dots on the local maximum, local minima, and maximum. And I did that for you already.
All of them?
Yep, there's 1, 2, 3,
Whoa,
4. That's
so
at the
much
turns.
work.
You've been finding the turns all along, and now you're just going to put dots at them. Okay? Letter I, I've done for you. Put the dots on it. Letter J actually isn't new.
I didn't get this. Can
okay.
we go over this one?
Yes, we're going to go over this. Okay, so it says if you divided the polynomial by x minus 1, would there be a remainder?
Yes.
And she said yes. You want to help us know
I
why?
don't know, I'm guessing.
She's a 50-50 chance, right?
Yeah.
X minus 1, if that is one of the factors, and if I set that to 0, what would be the 0?
1. And it doesn't cross.
Does it
directly
cross
across
at 1?
No.
It does not cross at 1. So if that means you would not have gotten you would have gotten a remainder. Remember when you got 0 as a
you put x minus 1 in parentheses equals 0. And if there's nothing crossing the 1, then you'll always have a remainder.
Yes.
Okay.
Okay? So if it crosses at the opposite of
Or
this.
if you look at like 9, it's x plus 2. So it would need to cross at negative 2 to not have a remainder.
So there is a remainder on number 1J. So yes.
What? I thought we said no. Oh.
Because it doesn't cross at 1, if you were to divide it, the polynomial, by this factor, it wouldn't go in evenly.
Oh,
Okay?
So there
So
will be
you
a
would get a remainder
because it doesn't cross.
because it doesn't cross. Yes. This is a lot of logic skills, not just algebra skills. That's why it's
That is why I
a lot of
just
reasoning
lost it.
skills. Okay?
Uh,
Number 17, I'm giving you a little bit of help. You've done some similar. Letter A, the complex zeros. How many complex zeros?
5.
Why do you know that?
Because of
5th degree.
It's a 5th degree. That means your reals plus your imaginaries is going to add up to 5. The possible real zeros.
1
5.
5 and then
3,
3 and then
1.
1. Okay?
Is it
So we
okay
go
if I do
from
1 through
5.
Can I do 1 through 5?
You can't do 1 through 5 because it's...
1, 3, 5.
Yes, you can do 1 through 5. Yes, you can. It's going to start at 5 and go down by 2. I'm going to write this out. We had
So the possible
5 here. 5, 3, 1. 0. Should be the imaginaries. The imaginaries plus the reals have to add up to 5. So if you had 5 reals, how many imaginaries would you have?
0.
0. So I'm going to write a 0. If you had 3 reals, how many imaginaries?
2.
2, because they have to add up.
2, 4.
And then if you had 1 real, you'd have to have, all the roots have to total 5. So if one of them's real, how many are imaginary?
I've got a question. 4?
4.
I'm down on letter D.
What We're going to do letter D now.
What's going on with the 5 afterwards? How do I use that?
Oh, I'll
when
tell
I
you what.
put
I'll tell
my-
you. Yeah, I got
when
it.
I'm changing
That's for letter E, okay? So letter D, the possible negatives and positives for right now, disregard this 5 at the end. It is going to help us with letter E. It is not part of the equation. The possible positives and negatives, I like to come over here and write my exponents 5, 4, 3, 2, 1, none. And then I like to come down below that and write positive, then negative, then negative, then positive, then positive and negative. Is everybody with me? What's the sign change in there?
There are
There's 3.
yeah.
3 sign changes. I got one right here. 1, 2, and 3. So that means there are 3 possible positive roots. That was for my positives over here. How do I do my negatives now?
Now you switch it if it's
Wi-
odd.
Switch it if it's odd. So if it's a 5 here, it was positive. That's why I put the 5 here. So since at 5 it's going to switch to negative, the 3 will switch to positive, and the 1 will switch to negative. Well, what will happen to all the evens?
They'll
3,
stay the same.
They'll
1.
stay how they are. Negative. Now how many sign changes are there?
2.
2. Okay.
I was gonna ask.
Now we're going to do letter E.
Since the 0 has been provided, would we do the I don't even remember what it's called, where we plug in the
It's called synthetic division.
Synthetic division, yeah.
Yes. Not pathetic division.
Same difference. I mean, let's be real.
That was
here.
a mom joke.
Some people think their dads tell weird jokes.
No,
All
my
right,
mom
before
told
we
me
do
to
that, can we factor by grouping at all?
Yes.
Would you like to factor by grouping, or would you like to do synthetic division with the 5?
5.
Factor by grouping.
If you do synthetic division with the 5, you're going to turn it into a 4th degree, and that 4th degree could be that synthetic. It could.
I got no idea what you're talking about.
Okay, so we could do
Let's do factor by grouping.
factor by grouping would be better. So factor by grouping, we're going to take this one together, that one together, and that together, and hopefully we're going to get something that's the same. What can I take out of the first
X
one?
to the
X to the
4.
4th.
All right, so I'm going to take x to the 4th, and I'm going to have left over x minus 5. Hopefully we're going to get an x minus 5 with the rest of those. I'm going to put a negative. What can I take out of the second one?
Negative 8x
Negative
squared.
8x squared. Do I get an x minus 5?
Yes, ma'am.
Fantastic. It's looking good that maybe we can do a factor by grouping. The last one, what can I take out?
A 12.
And I get x minus 5. That is so fantastic.
I think you bring it down, right?
Yeah, so I'm going to take my x minus 5. By the way, that is the factor of 5 that we told us that we were going to get. That is it, right? There's the factor and there's the root. What's left over?
X squared.
Careful.
X 4th.
X to the 4th minus
8 squared plus
8x
12.
squared.
plus 12. How do I do that one?
That one can be factored. Can
Is it one of those quadratic form ones?
I was gonna say, now do we have
Factor
to like,
the x
use the
fourth.
box method? Is that
Yes,
what's
very
going on?
good. That's the box
Ew.
method. X squared,
This is a lot.
x squared. What can I multiply to
I
make
know.
12 that adds up to 8 or subtracts to 8?
6 and 2.
6 and 2. So which one are they both negative? Were they both negative, both positive, or opposite?
Both negatives.
Both negative. I
Yes,
agree.
yeah.
Okay. So I'm gonna have
Negative 6.
x minus 5, x squared minus 6, and x squared minus 2. It doesn't ask us for the. Yes, those are the factors. I have just done E right here.
So f of x equals. got it.
Yes, let's just put the f of
Do
x.
we have
equals.
to put the f of x?
Yes.
The answer key does. If it didn't say write it in his equation, I'm gonna write it. Okay, F. We just set the zeros are easy once you've gotten here. Okay, now we set each of these equal to 0. What's x minus 5 set equal to 0? Positive 5. X equals 5. Some of you can do the next one in your head, and some are going to need me to write it out. I'm going to write it out for everybody who needs it. I'm going to set x squared minus 6 equal to 0.
Positive negative square root of 6.
Yes.
And same with
Oops,
the positive or
oops.
negative square root of 2.
Minus 6 equals 0. I'm going to move this over. to make it positive 6. I'll have x squared equals 6. And don't forget that you have a plus or minus. So the next ones here are plus or minus square root 6. Okay. This one is very much like this one. Change the 6 right here to be a 2. So that will be a 2.
Mm-hmm.
So what will I put here?
Plus or minus square root 2.
Very good. How many should I have here when I'm all done?
You can't just that.
I have 1, 2, 3, 4, 5. Should I have 5?
Yes, because
Yes, because it is a 5th degree polynomial. Remember, the irrationals become its conjugate pairs, and they did here. Do I have any imaginaries?
Yeah,
No imaginaries, so I had, it said, remember the possible numbers? I could have 5, and
how
that's
do you
what I
tell if
have.
they're imaginary or not?
Because they have an I.
Let me tell
Oh,
you.
yeah.
Okay.
I'm going to copy it down later.
Other questions? All right, here we go. Let's see what we've learned today. That's the new stuff. There's nothing new besides what those little bits and just putting them together. This is what we learned today. What are those bumps or turns called? What do we have a new term for them?
Maximum.
Relative max and mins. And we also learned how to find those max and mins on our calculators. Hope that's been helpful.